All right, it's time for chemistry. Okay, so let's do a quick review of the things that we've been learning in the last couple of classes so they don't slip away from our mind. All right? Now it's time to focus so that we don't have to re-review over and over and over. Yes, here it is. Here's my container where I'm going to put some sort of a liquid, right? And then here's my pile, or my little wave boat, and on it I have a pile of some sort of powder, okay? The powder is going to go into here and make something, the mixture, right? And we need to know the names of all these things. What is the mixture called, first of all?
Wait, which mixture?
After I've mixed the powder with the liquid?
Solution.
Solution. A solution. Now, a solution doesn't have to be a powder with a liquid. It could actually be two liquids, right? It could be two gases. Now, two powders doesn't really make a solution because they aren't homogeneously mixed always. I don't know if you've ever tried to mix two powders together. Have you guys ever done that before?
Yeah, like sugar and flour.
All right. When you make sugar and flour, the problem with mixing those together and calling them a solution is that if you shake a container like that of sugar and flour, they separate out, right? They divide
If you
themselves.
poured some water on that.
Put some water into it and make it kind of a mixture, then you can kind of get it more homogeneous. The thing with flour, though, is flour doesn't dissolve in water, does it?
This one's muddy.
It just makes it muddy, that's right. Cloudy. And that's how you can tell that something doesn't dissolve in water when it's cloudy. All right, so if I take something and mix it with another and the result is homogeneous, now the word homogeneous means that everything is mixed completely. No matter where you look, the concentrations of everything is the same. Right? That's a solution. What do you call this stuff that you're mixing in?
Solute.
The solute. And this stuff that you're going to have, this is called a solvent. Solvent. Solute and solvent. Now, and the result is a solution. Now, not like we just found out, or we just already knew, reminded ourselves, not everything dissolves or can form solutions, right?
Not everything is soluble.
Not everything is soluble, and some stuff's not soluble in anything, and not everything's for sure not soluble. There's a C right there. Not everything's soluble in water, right? Not very soluble.
If too soluble, you have to like.
Okay, now, some stuff's soluble, some stuff's not soluble. Okay? Now, we're going to start to talk about what happens when you have two mixtures, two solutions, combine them together, and out comes a what? Well, yesterday, who was here yesterday for class?
Oh, I was there for like 3 minutes because
Remember when I mixed those two things together? What happened?
Oh yeah, got cloudy?
It got cloudy. It got cloudy.
real cloudy.
And that, what color was the cloudiness?
White, blue.
It was blue. And remember then I put it into a what? I put it into a filter. Remember this filter?
Nope.
And I let it dry, and now look.
Whoa.
Is that iron again?
This is the copper sulfate, and it's just, now it's the copper carbonate. And it's just a powder now. Well, not again. This isn't copper sulfate. If I tried, I couldn't dissolve this in water. This is not
Why did you go to chemistry?
soluble. That's right, it doesn't dissolve in water. Okay? Well, because of its properties. Some stuff does dissolve in water, like, tell me something that dissolves well in water. Salt. Very good.
Sugar!
Some stuff does not dissolve in water,
Like cornstarch.
like
Flour.
like cornstarch. Now this is like flour and cornstarch. It doesn't dissolve well in water. However, the stuff that it was before did dissolve well in the water. That was copper what?
Sulfate.
Sulfate. So we want to begin to become familiar with why certain things and what kinds of things dissolve well in water. Now, there is again a special word for something that is dissolved in water. What's that? If it can dissolve in water, it's soluble. Once it is dissolved in water, we describe that solution like, for example, if I take some copper sulfate,
Wait, isn't the AQ?
that's right. Here's my copper sulfate, and if I want to tell you that it's dissolved in water, I put a little AQ here, which means aqueous.
That means it's already dissolved.
That's right. Not that it will dissolve in water, but that it's now currently dissolved in water. So this, if I go like
Is
this,
it only dissolved in water? It could be like in vinegar.
nope, aqueous always
Oh,
means
because
dissolved in water. Yeah, well, and yeah, that's why we
Latin
call
roots.
it aqueous. Here we go, copper sulfate. If I put S by there, that means what?
Solid.
Here's a big pile of copper sulfate. What color is copper sulfate though?
Blue.
Alright, I'm just gonna keep it green for now. If I, that's what the S means. That's what S means. Copper sulfate, S means solid, like that.
Well,
If I change this to L, what does that mean?
Liquid.
liquid.
How can I make that copper sulfate a liquid?
Well, by melting it.
Melting. That's right. Heating it up and getting it really hot.
Okay.
Right? It's not by adding water. If I add water,
It's AQ.
then it's AQ, and that would be like my container yesterday, right? A solution of
Orange liquids.
AQ. Okay? Very good. Copper sulfate, aqueous. Now, copper carbonate, CuCO3, what did we say about it?
That it does not dissolve.
It does not dissolve. So I'll never be able to put AQ here, right?
Never.
Solid.
Could you be able to do anything?
Yes. I could always heat something up and make it a liquid. That's a possibility. But you can't dissolve some stuff in water. There isn't, what are the little letters that we can have here? We have solid, what else do we have?
Liquid gas.
Liquid, gas, and what else?
Aqueous.
Aqueous, AQ. There's nothing else. There's no little symbol for something dissolved in alcohol, something dissolved in acetic acid. AQ, here, L, this is an L, first of all. Okay?
So what do you do if it's dissolved in vinegar or acetic acid or alcohol?
There's no way to express
You would
that
just say
in a chemical equation.
you'd have to put some sort of like note or footnote or something of some sort saying this element is dissolved in this.
Yeah, and you wouldn't express it as a normal chemical reaction like that. Or you would just include that as a reactant, right?
Oh, a chemical.
Yeah, that's a reactant. Okay, so now chemicals that contain sodium, potassium, lithium, rubidium, that's RG. Sorry. Chemicals that contain these ones are always soluble, can always be dissolved in water.
That contain
Chemicals that have these elements in them, rubidium. This is what? Sodium, potassium, lithium, rubidium. All right? They can always dissolve in water. Now, I'm going to hand out the periodic tables here because all of these elements are kind of in special locations. In special locations.
the very left.
The very left, that's right.
Are they the alkyl series?
The what?
Alkali.
Alkali. Alkaline metals, that's right.
What about hydrogen?
No, not hydrogen. But cesium, yes. And rubidium.
And what about Celsius?
Cesium. Yep, cesium too, also.
And francium. It's francium.
So everything in that first,
I found them all.
oh good.
They're all in the line.
Everything in that first column will all, if my compound contains those elements,
Hydrogen?
not including hydrogen. So this column right here, lithium, sodium, potassium, rubidium, and cesium, Any element, anytime a compound, contains those elements, it will be what?
Solvable.
It will be dissolvable. What's the fancy word for dissolvable?
Soluble.
Soluble.
Part 2.
You found it, huh? Good. They'll all be soluble.
This question is
All in one line.
Yeah.
This
Now, here's
question
another
is
one.
solvable.
Here's another one now.
I found titanium.
If a compound contains a metal in the blue zone.
Yes. Titanium.
Titanium? It's titanium.
Transition metal.
Transition metal. Can you see the blue zone there? The middle zone?
Yeah, what about the oxygen and carbon?
Oh, it can't go through the
Non-metals? He hasn't gotten there yet.
Oh yeah. Not, those are all non-metals. Do you guys remember the separation between the metals and the non-metals?
Metalloids.
There's a green staircase, right?
Green.
Can you see the green staircase?
Metalloids. I thought they were.
The green staircase separates the metals from the
It
non-metals.
says it are semi-metals, but I thought they were metalloids.
They have two different names. Those blue metals right there, if it contains one of those blue metals, are generally not soluble.
Unless they by themselves.
Any element that contains those are generally not soluble.
green.
Unless it has lithium with lithium or something with a metal, then it would.
All right?
But the cells,
Now, looking at these elements on this table, it's time to begin to talk about how compounds, how atoms like to come together to form compounds. Okay? How atoms like to come together to form compounds. Atoms like to come together as metals and non-metals. Metals and non-metals.
love each other.
Right?
The boys and the girls.
Can everybody hold up your periodic table and show me the staircase? Where is the green staircase?
I found it. So you
All right, that's the green staircase.
tiny for chicken.
So if I ask you a question about, for example, osmium, OS, is osmium a metal or a non-metal?
Non-metal.
How can you tell?
No, it's a metal.
It's not
metal. It's not on the. It's a metal.
It's not on the green.
It's a metal.
It's a metal. It's a metal. That green staircase separates the metals from the non-metals. What are there more of, metals or non-metals?
Metals.
Lots of metals, not very many non-metals, right?
Wait, but isn't everything else
One what?
Mostly like everything has metal.
What's that?
lots of metal? Everything except the blue and metal.
Everything to the left of the staircase are metals.
Okay, I'll do it.
Everything to the right of the staircase are non-metals.
I have 56. You guys are fighting
Those
over
are
one.
non-metals. Everything to the left of the staircase are metals. Those metals also. Oranges,
You
blues.
guys are only fighting over one metal. I'm
Well, isn't that funny? Hydrogen's not really a metal, but it's an exception. It's the one that's not a metal. Yes. So all the oranges, all the blues on the left, all the purples are all metals, except for hydrogen is the exception. All right. So how about this question? How about
What is the everything else over here?
greens are semi-metals or metalloids?
Hydrogen. Everything
Those
else.
two are the same colors as the rows behind them, or below. See the rows below? Trying to show that those little segments are supposed to match colors.
What? Wait, is UUS and are they metals?
They are kind of like metalloids, but we don't have enough of them to tell if they are metalloids, so we don't consider them.
And it says unknown under that.
Yes, and UUS, UUO is, or UU, what is it, UUU? UUO. Those are just abbreviations for how you say 115, 117, 118 in Latin. So those aren't actual names. All right, So we're beginning to talk about how elements are going to come together to form compounds. And this is necessary if we're going to understand why certain things dissolve in water and why certain things don't.
Well, a mineral could be a rock. A metal could be a rock, right?
Yes. Yep.
So in chemistry, a rock is considered as a metal.
Well, when you say rock, are you just meaning a chunk of a solid?
Yeah.
Because carbon can be in a solid chunk like that too, but it's not a metal. All right, thank you everybody for coming today. Please gather all the periodic tables and hand them to, or set them on the table.